Welcome to Kaveri Code. I'm Deobroto Acharji. Let's discuss SHA-1. So, imagine if you have a bank server that contains all your password, and imagine you have the file in which the passwords are written, and then you connect with your PC and set up your account with your user ID and password. And imagine something bad happens. Your password gets stolen because of a data breach. It reaches the hands of malicious people, but you are safe because thankfully your passwords were hashed. So your password, if it is taken from the file, it came from your password, but your password cannot come from it. This is called hashing. So hashing is basically converting a fixed length of text into converting any length of text into a fixed length of gibberish, because something that you will not understand, but that will be very random, and it will store your value, but you cannot get it back. So now let's say you have welcome to Kaveri code. So that the hash is this. For welcome to Kaveri code, this is the hash. So this is called a digest. You hash is a process, this is called a digest. But if you change the message slightly, then your mess the output changes drastically. So your digest basically changes completely, and it is very therefore very difficult to predict uh, how to it is very difficult to predict like what it actually means. Let's say if you have this and you have this, and then I give you this, you can't predict this. So it's basically a process, and the output is called a digest, and that is of a fixed length. So SHA-1 basically, this is an SHA-1 of welcome to STV. So now secure hash algorithm. So there are many others, MD4, MD5, and there are many others. But secure hash algorithm has SHA-1, SHA-2. So SHA-1 was the first one, then SHA-2 that is very secure, and SHA-3 that is very very secure. But SHA-2 is mostly used. So SHA-1 was released by the NSA in 1995, and it's basically creates digest of 160 bits. Like basically, and you give it one line or a movie of 5 GB, it basically creates 160 bits of hash. So basically, how what it does is it takes 512 bits. This is very important. It will take in as an input a 512 bit, and then it will hash it. So but the problem is, let's say you have a very small message, let's say just ABC. So if you have just ABC, then that's only 24 bits. Then how do you hash it? So what we will do is we will do some padding. So we will add some extra material to make it 512. So what we will do is first we will add a 1 bit, so it will make it 25 bit. Then after that one we will make add a lot of zeros, so it will make it around 448 bit. It will, so we will make as many zeros as required until it is 448 bits. Remaining bit, what we will do, we need to know until what point is the message. So basically we need to add the length. So your 24 bit, it was 24 bit initially. So 24 bit is basically represented by this, and we will add it to a particular minimum length. So basically it will be, this will be 24 bits. And now what we will do is we will add this with the message, this with the message, so we will get this whole padded message. So this is padding. So now let's say we have padded a value. Now what we need, how does SHA-1 works, the internal working? So there are um, 5 states: H0, H1, H2, H3, H4. Each one of them are 32-bit like random values. They are derived basically, they are pseudo random values. They are derived basically from basically root of prime numbers, because root of prime numbers are irrational numbers. If your math isn't coming back to you, irrational numbers are those numbers which vary a lot and which doesn't repeat itself, like 1.5267, then dot 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 dot, it will go on randomly. Rational numbers will be like 1.525252, it will come complete like that. So those are rational numbers. So basically it's a irrational numbers which are very random, so that will give us a very that will give us a very random pseudo random digit which varies a lot. That's why the input message, if there is a slight change, the output will vary a lot. So we have this h0, h1, h2, h3, and h4. Now what we will do is we will take these values and now we will copy them into some like other variables. For avoiding confusion, I'll just call them a, b, c, d, and e. So if we have a, b, c, d, and e, then what we will do is, after we take these values, which are basically h0, h1, h2, h3, and h4, we will take the message. We will take 512 bit of either the original the total message or the padded message. So we'll take the message, and based on these bits we will shuffle them. So we will shuffle these bits like paste, and not in a simple way but in a complex way. You can go through the bitwise equation, but that's not the point. The point is, the according to the message the bits will be shuffled. So the shuffling of the bits will be dependent on the message, or on each bit of the message. And that is not like, let's say some bit is moved 4 times, shifted right 4 times, some like left 2 times, depending on the message. So it will not be the same. So you will have your new a, B, C, D, and E, which is basically a shuffled version of the A, B, C, D, and E we had based on this message. Now, what we will do is we will take this message, and we will then, what we will do is we will bring this here and we will add it. So basically we will add A, B, C, D, and E to the original H0, H1, H2, H3, and H4 to get a new H0, H1, H2, H3, and H4. So that is how we get our 160 bit of hash. This is what we call the digest, the 160 bit of digest. Now let's say our file is not just abc, it's basically a movie of 5 GB. So what we will do, we will basically have lots of blocks of 512 bits. But for what we will do is, one by one we will call each of those bits, and according to them we will do this over and over. We will send this back to the initial value. We will send this newly obtained value to the initial value, and we will continue this process for as many number of blocks we have. And the final time we have h0, h1, h2, h3, and h4, those will be our hash. So this is how it works. I hope you understood. Write down in the comments below. Thank you.